Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nabil bin Muhammad Noor. So tonight I'm going to present about the presentation for the report for alcohol detection system pre-ignition in cars. So at the start, so for the introduction, so in these modern days, cars have become one of the basic needs for mankind to move from one place to another via roads and highways. But car users, or to be exact, the road users from around the world, particularly in Malaysia, are facing a common issue which is the drunken car driver. So this project is needed to reduce the number of accidents caused by the drunk drivers, thus reducing the total accidents in Malaysia. So by using the alcohol detection system, it will imply the reduction of cases involving drunken driver. Not only it guarantees the safety of the other road users, but it also put themselves in safety by the additional safety precaution system. So this is the two main parts that I use for this project. Firstly, the alcohol gas sensor, and secondly, the Arduino Uno. For the problem statement, a blood alcohol content BAC level of 0.08% is considered legally impaired, but alcohol can start to affect many of these senses after only one drink. And no matter what situation, one should never drink and drive. The vision of the drunk drivers are impaired as all the surrounding seems blurry, endangering themselves and the other road users nearby. So this project would prevent the drunk drivers to drive. This detection system will make the car ignition system locked from being turned on due to the presence of the alcohol nearby the driver's car seat. By embedding this to the conventional ignition system in cars, it is assumed that the number of road accidents, will decrease. So this is the example of the impaired vision of the drunk driver. Figure 1.22 shows the statistic of drunk driving accidents in Malaysia. So for the objective part, the main objective of this project is to reduce the number of accident cases caused by drunk driving. Thus, the sub-objective of this project are classified as the following points. Firstly, is to design a working alcohol detection system embedded in the car ignition system by using Arduino Uno microcontroller and combine it with the alcohol sensor. And second, to stimulate the utilization of this system and its effectiveness to the car drivers, possibly under alcohol influence. So for the scope of work, the scope of this project is to design a system or model that could detect the alcoholic gas from the driver to block the ignition system. This project is using Arduino Uno microcontroller, the alcohol gas sensor, and the blocking mechanism. It will only block the ignition system after the alcoholic gas is sensed. The microcontroller in this project will trigger the system and the alarm as the signs that the drivers are not eligible to drive under alcohol influence. The testing will be done to the working model of this system. And this is the crucial part, the literature review. This chapter emphasizes on Arduino Uno R3, MQ3 gas sensor module, which is an alcohol sensor, and the use of alcohol detection in cars and the past studies regarding alcohol detection utilized in cars. So the Arduino Uno is the finest board for beginners, for novice who wants to learn about the electronics and programming. The Uno is one of the most useful board that can be started with for novice users. The Arduino Uno is the most popular and well documented board in the Arduino family. And the Arduino Uno R3 hosts the processor, the Atmega 328. So the Atmega basically is the IC chip inside the module. The Atmega 328 is the Arduino Uno R3's host processor. The 328 is an 8-bit microcontroller with 28 pins. The processor's architecture is based on the reduced instruction set computer arrays principle, which enables it to handle 20 million instructions per second MIPS at 20 megahertz. So the following system are useful for categorizing the features, which are the memory system, interrupt system, port system, serial communications, timer system, analog to digital converter ADC. So this is basically the I show you the Arduino Uno, if you can see. So this is the Arduino Uno R3 system. Can take a look at this. If it's not clear, I prepare it in the report for reference. So next, the MQ3 car gas sensor module for ethanol C2H5OH small. So this is the gas sensor module. This analog gas sensor MQ3 can be used in a breathalyzer and is ideal for detecting alcohol. High alcohol sensitivity and low benzene sensitivity characterize it. The potentiometer allows for sensitivity adjustment as depicted. Specifications are power supply needs 5 volt, interface type analog digital, high sensitivity to alcohol and small sensitivity to benzene, fast response time, stable and long life, simple drive circuit, and the size is not that big, it's around 32 multiplied by 20 millimeter. So this is show you again the MQ3 gas sensor module. And this is basically the exploded view. No, it is not an exploded view. This is the parts for the module, and the materials as shown as in the table. So for sensitivity adjustment, the resistance of MQ3 differs from gases of various types and concentrations. Therefore, sensitivity adjustment is crucial when employing these components. It is advised that the detector be calibrated for an air alcohol concentration of 0.4 milligram per liter, about 200 ppm, and use a load resistance value of 2000 K. Oh, sorry. In vehicle technology like the driver alcohol detection system for safety DADSS, or I call that DADS, are being developed with the goal of preventing alcohol impaired drivers from operating their automobiles. DADS in vehicle sensors are meant to immediately detect whether or not drivers have consumed alcohol and to quantify blood or breath alcohol content accurately and precisely. The car will be immobilized if the driver's blood alcohol content, the BAC, is at over a predetermined limit. So, in simple terms, if the car detected some kind of high level BAC or maybe the predetermined BAC, so the car will be immobilized, will be stopped. Next, the methodology part. This concept would function by detecting the presence of alcohol in its gaseous form through a person's breathing when they started their car's engine. The alcohol sensor would transmit a signal to the Arduino controlled microcontroller when the system in this model detected the alcohol. The car's engine would then become impossible to start. In this case, it is the DC motor. It will not rotate, and the user would be further alarmed that they are under the influence of alcohol by the buzzer and the LED alert. So basically, this is the workflow for the architecture. If the alcohol detection, then the driver breathes close to the sensor. If the alcohol is not present, the microcontroller allows the ignition circuit as closed circuit by relay, and buzzer and warning LED are turned off. They're not warning anything, and engine can be ignited, or maybe we should say that the DC motor can be rotated. So if the alcohol is present, the alcohol sensor send a signal to microcontroller, and microcontroller will make the ignition circuit as open circuit by relay. Uh, Buzzer and warning LED are turned on. Engine cannot be ignited. So for the software development, Arduino IDE software is in personal computers. In my PC is used to write and execute the code into the Arduino Uno module. So basically, I use Arduino IDE software. Can be downloaded from the Arduino website, official website. For the hardware component, I use the MQ3 gas sensor, Arduino Uno R3, DC motor, L293D motor driver IC. It is used to separate the circuit and the DC motor circuit. So for the preliminary result, this project, the circuit contains motor with switches and LEDs are attached to the MQ3 gas sensor. This circuit will be tested by putting the sensor near the alcohol source. For that purpose, a sample of beer which mainly contains ethanol are poured into the lid for detection. For the alcohol detection, a sample of alcohol beer from the Carlsberg brand are put into a lid cover as a container, and then the MQ3 gas sensor would then be put nearby the alcohol samples, the indicator whether the buzzer and the LED will turn on or not. So basically, this is the detection process. So the red light here indicates that it does not detect any alcohol. So the green one here indicates that the system is detecting the alcohol. If you look closely at the gas sensor must be put closely to the source, because I don't know why. Maybe we must need the calibration in the algorithm to make sure that it will detect alcohol from distances. So this is the overview of full circuit. This is I call the prototype one, or maybe the first model for the circuit. So for the conclusion part, the alcohol detection is very significant analog parameter that is actually regarded as vital sign for detecting the alcohol from the car user or driver. The use of the microcontroller will create path to integrate the function of sensors, alarms, and controlling the final output, which is the engine. In this case, it is represented by DC motor, so they can work in a synergized manner in terms of detecting the presence of alcohol pre-ignitions in car. And for the future work in this project is to appropriately modelize this project into a suitable container or mini container, and alcohol detection distances would be recorded by many varieties to determine the result. So this is the reference. So I think that is all from me. Thank you. If you don't have any question, if you have any questions, maybe you can refer to the report. Thank you.